one reminder to start with today. Yesterday I was talking about if we have a number and then I put a little plus symbol up in where the exponent should go. Okay? So if I put a little plus symbol up there, that means one of two things. The first thing that it means is if I am talking about an x value, that means that I am coming in to that number from the right. Okay, so if I say like as x approaches 2 plus, with a little plus up there, that means x is approaching 2 from the right. If I'm talking about a y value, then we're talking about coming from above. Okay. F of x approaches 2 with a little positive, with a little plus symbol, that's approaching from above. Okay? If we switch that symbol, instead of it being plus, to a negative or a subtraction sign, or a minus, if you will, and then we're talking about an x value, now we're talking about from the left. And if it's a y value, we're talking about from below. We need that in end and asymptotal behavior, because we need to talk about where it's coming from, where the function is going. Okay? Fraction logic, remember a number divided by a big number, or a bigger number I should say, is going to go to 0, and a number divided by a smaller number is going to go to infinity. Okay? So those 3 reminders off the start. Okay? So we'll pick up with notes now, then. Okay? So it says find the domain, vertical asymptotes, and use logic to describe asymptotal behavior. That's what the function is doing at the asymptotes. And the end behavior. Okay? So the first thing that we need to do to find the domain is I set the denominator equal to 0. That's how I find domain. X minus 4, I set that equal to 0, and I solve that. Easy solve, x equals 4. So that would give me a domain at 4, my denominator is 0, and a denominator of 0 is bad, so I don't like it, so I kick those values out. So the domain, is all real numbers, but x cannot be 4. If x is 4, we have a denominator of 0, and it doesn't work out. The nice thing about that, about finding the domain, is we've automatically found our vertical asymptote. In this case, there's only one, and it's a vertical asymptote of x equals 4. It's just the vertical asymptotes are the restrictions in the domain. Question came up in the last class. Do I have to write it as x equals 4? Can I just write it as 4? And the answer to that is no, you have to write it as x equals 4 because an asymptote is a line and it needs to be in linear form. Linear form is y equals mx plus b, or in this case, because it's a vertical line, x equals some number. Okay? So that's domain and vertical asymptote. Now we're going to use logic to come up with the end behavior and the asymptotal behavior. Let's do end first. So that's going to be as x approaches infinity and as x approaches negative infinity. My function, once again, was 1 over x minus 4. Right? Was it 1? Yep, it was 1. Okay? So 1 over x minus 4. If I put in a number that is approaching infinity, so that would be like a ginormous positive number. Okay? So that's going to be 1 over a huge number minus 4. Well, if I'm taking a number that's approaching infinity and I subtract 4 off of it, that's like taking 1 grain of sand off the beach. Okay? Not really going to make that big of a difference, right? Okay? So that's going to be 1 divided by a positive huge number. Okay? Fraction logic tells me that that's going to be, I don't even really care about what the numbers are. That's going to be a positive divided by a positive, which is going to go to 0 from above. Because it's positive divided by positive. Now, if I put in negative infinity, that's going to be positive 1 over a negative huge number. When I subtract 4 from a negative huge number, it's getting even huger. Okay, it's getting bigger by 4, which isn't really that much when we're talking at infinity, but still. Okay. So that's going to be a positive over a negative. Positive divided by a negative is negative. So this is going to go to 0 from below. Now we can talk asymptotal behavior. As x approaches 4 from the left, what is my function doing? And as x approaches 4 from the right, what is my function doing? Again, my function was 1 over x minus 4. So if I approach from the left, so I want to be a number that's left of 4 on the number line. So that's smaller than 4, but really, really close. So I'm going to go something like 3.99. If I put 3.99 into my function, I get 1 minus 3.99, or excuse me, 1 over 3.99 minus 4. 1 is positive, correct? $3.99 minus 4. Is that positive or is that negative? Negative, and it's really small, right? So a positive number divided by a negative small number is going to go to negative infinity. Because the closer I get, the smaller that number gets. What's wrong? Where? What do you got, Tom? I needed a number close to 4, but on the left side of it. Okay? I could have chosen 0, but that's not close to 4. You know what I mean? I want it because x is going to 4 from the left side. So 3.9, 3.99, 3.999, 3.99999, and stuff like that. Okay? Now, I'm going to 4 from the right. So I'm going to choose something like, oops, wrong color. I'm going to choose something like 4.01. Colin, what's your question?
I was just asking what the difference between the end behavior was and the asymptotal behavior.
End behavior is the left and the right side of the graph. Okay? Asymptotal behavior is at the vertical asymptote. Which is why for end behavior it always goes to infinity or to negative infinity. Because to infinity is the right side of the graph.
And then your asymptote
Goes to wherever your asymptotes are. So if I had 2 asymptotes, I'd have to do 2 different sets. One from the left of each and one from the right of each. Okay? In about 2 minutes. Okay? So this is going to be a positive number on top. 4.01 minus 4 is going to be a positive small number. Oops, let me redo that. That's not very good writing. A positive small number. So positive divided by a positive is going to go to positive infinity. Okay. Again, I'm not really worried about what the numbers are doing there, or what the actual numbers are, because end behavior is going to go to a certain value, and I'm going to tell you what that value is here in about 20 minutes. Okay? Asymptotal behavior is always going to go to infinity, because it's got to make a curve. It's either going to curve up or it's going to curve down, because it can't cross over. Okay? So I just need to know positivities there. You try example number 3. reading directions is kind of important, right? Because do I have to do end and asymptotal behavior on this one? No, I don't have to on this one. I just need to find the domain and the vertical asymptotes. Okay? So, yep. Okay. So I set denominator equal to 0 right from the start. So x squared minus 9 equals 0. Most of you from walking around added 9 first and then took the square root, which is fine. Totally legal in this case. That gives me x equals, lots of you just put 3. Okay? But what's wrong with just 3? There's got to be 2 answers because the degree is 2. So whenever I take the square root, I need to add plus or minus. Okay? So the domain here is going to be all real numbers, but x cannot equal plus or minus 3. And I'm okay with it written like that. If you wanted to write it as plus 3 comma minus 3, that's fine too. If you wanted to split them up. Okay? My vertical asymptotes, however, need to be split up because they are 2 separate and distinct lines. So those we have to write as separate. In the domain, they can be combined with plus or minus, but when we're writing asymptotes, only one. Okay? And that's where we had to stop because the directions didn't say do any of that other goofy stuff. Okay? However, whoops, went too far. However, now they say it. Okay? So now, find me the domain, find me the vertical asymptotes, use logic to describe asymptotal behavior, and logic to describe end behavior. I will give you 5 minutes. Alright, so, first thing, denominator equals 0, so x squared minus 25 is going to equal 0. X squared is going to equal 25, so x is going to be plus or minus 5 there. So the domain here is going to be all real numbers, but x cannot equal plus or minus 5. Vertical asymptotes, then x equals 5 and x equals negative 5. Agree. Okay. So there's that through there. Now we just have to do end and asymptotal behavior. I think I can get end in here with this on there. I'm going to call it end behavior. I'm going to call it EB from now on. So as x goes to infinity, where is my function going? And as x goes to negative infinity, where is my function going? Okay? So if I put in a ginormous number, positive number, right? Okay? So I put in a huge number, that's going to give me on top a ginormous, huge number, right? Right? Okay? Then I got to square that same number, right? Well, when you square something, you're multiplying it by itself, so that's going to be even bigger, right? And it's still going to be positive. So it's going to be a positive, huger number, and then I'm going to subtract off 25, which again is like taking 1 grain of sand off of the beach. Okay? So I'm going to have a positive huge number divided by a positive much bigger number. That's going to be 0 from above because they're both positive. Negative infinity now. Now I'm going to have a negative huge number. And I'm going to divide that. First off, I got to square it. Negative huge number squared. It's going to turn into a positive, right? So that's going to be a positive huger number minus 25. So now I'm going to have a negative divided by a positive, which is negative divided by a positive. It's going to be negative, so that means I'm going to approach 0 from below, because below is the negative side. Okay? Now let's go to asymptotal behavior. As x goes to negative 5 from the left, my function is going to go to some kind of infinity. As x approaches negative 5 from the right, my function is going to go to some kind of infinity. As x approaches positive 5 from the left, my function is going to go to some kind of infinity. And as x approaches positive 5 from the right, my function is going to go to some kind of infinity. I just got to figure out what kinds of infinity now. Okay? So my function again was x over x squared minus 25. So I need a number to the left of negative 5. That's going to be negative 5.01. If I put that number in there, okay, I get a negative number on top, correct? I get negative 5.01 on top, right? If I square 5.01, is that number, first off, it's going to be positive, right, because I squared it. Is that number going to be bigger or smaller than 25? Why? So it's going to be bigger than 25, right? Okay. So it's going to be a little bit bigger than 25. And then I'm going to subtract off 25. Is that going to be positive or negative? It's going to be positive, and it's going to be small. Okay. So fraction logic tells me that that's going to go to negative infinity. Negative divided by a positive is negative. That function is going to turn down on the left side of this asymptote. Now, number on the right side of negative 5. Negative 4.99. If I put that into the top, I get a negative number. When I square negative 4.99, is that going to be bigger or smaller than 25? Smaller, because 4.99 is smaller than 5. Subtracting 25 then is going to give me a negative small number. Okay? You can always do this math. Okay? You can always square negative 4.99. There's one. Oops, clear. 4.99 times 4.99 gets me 24.9001. Right? And I subtract off 25, gets me negative 0.0999. Okay? Negative divided by a negative is positive. Okay? we go to the positive side. So the left side of positive 5 is going to be 4.99. So these are just going to, the top is going to change to a positive, but the bottom, the logic is still the same because we're squaring. Positive divided by a negative is negative. And that one goes to positive. Logic stays the same. Graphing it. And then reading your graph.
When we take this over, that's like the sum that we use a graphic calculator.
Nope. Nope. This is a non-graphing calculator's unit. Yep. Okay. All right, so get out that extra supplemental sheet that I had, okay, for you, because that's going to be helpful right now because we're going to add in another step. You should already have on there step number 1. Step number 1 said find the domain in any and all vertical asymptotes. Remember, vertical asymptotes occur at values of x where q of x is equal to 0, or we simply said that that is where my denominator is equal to 0. And I use that to find restrictions in my domain, which then finds me vertical asymptotes of my function. Okay? Fantastic. Now, what I want you to do is I would like you to skip on your extra note sheet. I want you to skip down a little bit. Okay? So you should skip like 3 lines and then start number 2. Because next week I'm going to fill in a step 1.5. Okay? But we're not ready for step 1.5 yet. So that's why we're going to go right to step number 2. Okay? Step number 2 says we are going to find the horizontal asymptote. And the horizontal asymptote is extremely important for us because it's what our function is going to on the left and the right sides of our graph. Our function will approach the horizontal asymptote on the left side and on the right side of our graph. Okay? So that's why the horizontal asymptote is extremely important for us. It's that number that when we're doing these end behaviors, it's that number right here. It's that number that that's going to go to. So far, it's been 0. And I've intentionally made it be 0 so far. But now, it's going to change. Okay? Because now we can take a step forward. So, what's going to happen? The process that you are going to use is you are going to compare the degrees of the numerator to the degree of the denominator. And remember, degree is the biggest exponent. So effectively, we are comparing 2 numbers. Okay? When I compare 2 numbers, only 3 things are possible. Either one number is bigger than the other, it's smaller than the other, or they're exactly the same. That's the only 2 things, or only 3 things I can get when I compare two numbers. Bigger, smaller, or the same. Okay? So, if the top degree is greater than the bottom degree. So you have big over small. There is no horizontal asymptote. And you would write none. You write HA colon none. Because there isn't. Okay? So top is bigger than the bottom. Second choice, top is smaller than the bottom. This is what we've been doing so far. Okay? Top is bigger than the bottom, so now we've got small over big. And then y equals 0 is our horizontal asymptote, our HA. Our last possible comparison is if the top is equal to the bottom. So if they both have the same degree, then my horizontal asymptote is the line y equals a over b, and a and b are the lead coefficients oops, that's bad. Didn't write good. Done, did, didn't. Of the top and the bottom. Okay. So if they're the same, lead coefficient, top and bottom. For instance, if I had f of x is equal to 2x over x minus 3. The degree of the top is 1. The degree of the bottom is 1. So then I go and I look at the lead coefficient of the top, which is 2, and the lead coefficient of the bottom, which is 1. So my horizontal asymptote here would be y equals 2 over 1, or just y equals 2. Okay. Find the domain of the function and identify any horizontal or vertical asymptotes. Okay. So, if I'm looking at number 5, first thing I'm going to do is I'm going to say x plus 1 equals 0. So then that gives me x equals negative 1. Set the denominator equal to 0. Step number 1. Okay? So the domain of this function is all real numbers, but x cannot equal negative 1. Which gives me a vertical asymptote of x equals negative 1. Agree with that? That's step number 1. Step number 2 now says we need to find the horizontal asymptote. So I look at the degree of the top. What's the degree of the numerator? 2. Biggest exponent is 2. What's the degree of the denominator? 1. Okay? So is top bigger, is top smaller, or are they the same? Top is bigger, so this is a big over a small case. So what does that mean from my cheat sheet? None. Okay. You try number 6. X squared minus 9 equals 0. So that gives me x equals plus or minus 3. We did that a couple of times today already, so I'm going to show all the work on that one. Agree? So that tells me that my domain is all real numbers with the exception x cannot equal plus or minus 3. Vertical asymptotes are what? X equals 3 and x equals negative 3. Okay. Degree of the numerator.
6.
Degree of the numerator. 2. Degree of the denominator. 2. Bigger, top smaller, top the same. Same. Okay, so since it's the same, what do I look at? Lead coefficients. Lead coefficient of the top, 6. Lead coefficient of the bottom, 1. Okay, so my horizontal asymptote is going to be y equals 6 divided by 1, which is just y equals 6.
For the vertical asymptotes, you have to write them separately.
Yes, because they're 2 separate lines. Okay. What I would like you to do now is I would like you to do number 7. Find the domain, vertical and horizontal asymptote, end and asymptotal behavior. I can take the cube root of both sides when I set the denominator equal to 0. Cube root of x minus 2 quantity cubed is just x minus 2. Cube root of 0 is 0. So then my condition is x equals 2. So my domain then becomes all real numbers with the exception of x cannot equal positive 2. That tells me that I have a vertical asymptote at x equals 2. Degree of the numerator. 1. Degree of the denominator. 3. Biggest exponent. Okay. So I have a 1 over 3 case. That's small over big. That's y equals 0. Okay. End behavior, asymptotal behavior. End behavior as x goes to infinity, my function is going to go to 0. I just need to figure out if it's going from above or from below. But I know it's going to 0 because 0 is my asymptote, my horizontal asymptote. So I know that's 0. If this was like 7 there, I would say then f of x is going to 7. I just have to figure out if it's above or below. Okay? Likewise, as x goes to negative infinity, my function is going to 0. I just have to figure out above or below. So if I put in a super ginormous number into 4x over x minus 2 quantity cubed, if I put in a really big number, positive, I'm going to get a nice big number on top. But it'll still be positive, right? On the bottom, I'm going to cube that nice big number, and it's going to be even much bigger, right? So that's going to be a positive divided by a positive, which is going to be a positive, so it's going to come from above. If I put a negative number in there, I get a negative number on top, correct? On the bottom, I get a negative number cubed. What's a negative number cubed? Still negative, right? So I've got a negative divided by a negative, which is positive. That one also is from above. Asymptotal behavior. As x approaches 2 from the left, my function is going to infinity. I just have to figure out which one. As x is going to 2 from the right, my function is going to one of the infinities. So again, if I put in a number left of 2, like 1.9, if I put that on the top, I get 1.9 times 4, which is a positive number. If I put 1.9 on the bottom, I get 1.9 minus 2, which is negative, right? And then I cube that. So it's going to be a negative number on the bottom. Positive divided by a negative is negative. If I put in 2.1, on the top I get a positive number. On the bottom, 2.1 minus 2 is positive. Cube of a positive is positive. So that one's going to go to positive infinity. Okay? Now, before you pack up, what I would like you to do, by class tomorrow, your homework for tonight is, I want you to do the exact same thing on a separate sheet of paper, because I'm collecting it tomorrow. I want you to do number 8. So I want you to do homework problem, or excuse me, class example number 8 as a homework problem due tomorrow. Okay? Find me the domain, find me the vertical asymptote, find me the horizontal asymptote, end and asymptote behavior. Okay? Have yourselves a great day.